All right, we are going to go over the math test problems from SHSAT practice test number 3. The test link is in the description of the video. It is just 5 math questions. So go ahead and give yourself 10 minutes. Time yourself so you can practice pacing for the day of the test. And if you're done, let's go ahead and dive into these and see how you did. So number 68, we're given a table that shows us the number of people in a vehicle and then the percent of vehicles, and these are people per vehicle at a given checkpoint. And the problem says a researcher recorded the number of people in each vehicle that passed through a checkpoint. The table above shows the percent distribution for the 420 vehicles that had passed through the checkpoint yesterday morning. How many of the 420 vehicles contained at least 3 people? So the first thing I'm going to do up here is just annotate that I know these vehicles are 420. That's the number of them. And now the information they want is how many of those vehicles had at least 3 people in it. So when I look at this table, I know that I am considering the vehicles that had 3 people in it, 4 people in it, and 5 or more people in it. All of those vehicles qualify as 3 or more, as at least 3, right? So that means that the percentage of vehicles I'm looking at is the sum of these 3% here, which is 25%. And so what I really want to know is, what is 25% of the total vehicles? And those total vehicles are 420. So we're just calculating 25% of 420. Remember, you don't have a calculator. A couple of different ways to do this. Because 25% is an easy benchmark percent, right? This means the same thing as a fourth of 420. So that means you're really just dividing 420 by 4. So we can go ahead and do that and get our answer of 105. Now you can also do this percent problem by doing 0.25 times 420. You can set up a proportion, but either way you do it, as long as you know you're looking for 25% of 420 and you calculate correctly, you should get 105 vehicles. All right. Moving on to number 69, we are given a pyramid and we're told that each triangular face has the same area. And the base, MNPQ, is a square that measures 8 centimeters on each side. All right, so I'm going to go ahead and label that. If the length of RS is 6 centimeters, so RS, and as I highlight RS in blue, you'll notice that RS, even though, sorry, I sort of hit it in red, has this 90-degree angle symbol here. So I know that RS is the height or the altitude, and that is 6 centimeters. So I'm going to label that. Oops, sorry. And they want to know, what is the surface area of the pyramid excluding the base? So we know that surface area means that I am adding up the areas of all of the faces of a prism, but they want me to exclude the base. So that means that I'm going to add up the areas of the 4 triangular faces that are on this pyramid. But because they're all equal, I know that what I'm really doing is 4 times the area of 1 triangular face. So as long as I find the area of 1 triangular face, I can just multiply that by 4, and that will give me the surface area. All right. So because I'm dealing with triangles, I know that the formula I'm looking for is half the base times the height. I'm going to bring down this 4 times. So I know I'm not going to forget that. So I need to multiply 4 times half the base times the height. So now I'm going to go ahead and substitute in the values I know. So 1/2 times the base of each of these triangles is part of the square base that pyramid has. So that base is 8. The height is RS, that segment RS that formed the 90-degree angle with one of the bases. So that is 6. And now it's just a matter of correctly evaluating this. So 1/2 times 8 times 6. 6 times 8 is 48. Half of 48 is 24. And I have 24. So that means that the area of each of the triangular faces is 24 centimeters squared, and there are 4 of them, so that's why I'm multiplying 4 times 24, which will give me 96. So 96 square centimeters is my answer. Number 70, the perimeter of a rectangle. So let me stop right there and go ahead and annotate this as 2L plus 2W. I know that in a rectangle, the 2 lengths are equal in measure and the 2 widths are equal in measure. And perimeter means to add up all the sides. So I can look at the perimeter as L plus W plus L plus W, or more simply as 2L plus 2W. So I know a formula for my perimeter. I'm told that the perimeter is 510 centimeters. So that means I can write that 2 times the length plus 2 times the width will equal 510. Now it tells me that the ratio of the length to the width is 3 to 2. So let's draw this rectangle again. And they're telling me that if the length is 3x, the width is 2x, right? They're telling me the ratio of the length to the width is 3 to 2. So I'm going to call the length 3x and the width 2x. And they want to know the dimensions, meaning the length and the width of this rectangle. So I have the formula written over here. And now I have expressions that represent the length and width. So I'm going to substitute them into this formula. So now I'm going to write 2, and instead of writing L for length, I'm going to write 3x because 3x represents my length. Plus 2, and instead of writing W, I'm going to write 2x because 2x represents my width. Equals 510. Now I'm going to go ahead and solve this equation. So I have 2 times 3x, that's going to give me 6x, plus 4x equals 510. That gives me 10x equals 510. Divide by 10 on both sides to isolate the variable, and that gives me x equals 51. Now, once you solve for x, that's not necessarily the answer to your problem. We have to go back and see what they were looking for and see if what they're looking for is represented by x. And if it's not, I have some more work to do. So they're asking me to find the dimensions meaning the length and the width. So x equals 51 is not my answer, but it helps me find my answer. The length, as you see in my picture above, is represented by the expression 3x. Well, now I know what x is, so I can replace x with 51 because I found it to be 51. And now if I just multiply, I'm going to get 153 as my length, all right? Now, I know you already see the answer choice that has 153 in it, but let's just calculate the width to be sure. So the width is represented by the expression 2x. I'm going to replace that x with 51 and just multiply to get me 102. So I have a length of 153 centimeters and a width of 102 centimeters, and that is answer choice F. Number 71, which number line below shows the solution to the inequality -4 is less than x over 2, which is less than 2? So first and foremost, I noticed that my inequality symbols do not have the or equal to. So I want to make sure that my graph has unshaded or open circles, all right? So that if I see any shaded or closed circles, I can eliminate them. Now, all of my answer choices do have open circles, so that doesn't help me eliminate anything, but on the test, you might get a problem where you can eliminate something that doesn't match up with the inequality symbols you have. All right, so that didn't help. Now I have to go ahead and solve this inequality. So I'm trying to get that x alone in the middle of the inequality. So right now the x is being divided by 2. So the inverse operation of dividing by 2 is multiplying by 2. So we're going to multiply each part of this inequality by 2. So -4 times 2 is -8. In the center, I'm just going to have x because this is essentially the same thing as 1/2 x, right? So 1/2 x times 2 is just x. And then all the way on the right side, I have 2 times 2, which is 4. Now, in case you're thinking about flipping the inequality symbol because of this -4 here, remember that you only do that if you multiply or divide by a negative number. So not into or not to a negative number, but by a negative number. And we did not multiply by a negative number. We multiplied by a +2. So there's no need to change any inequality symbols, all right? So we are looking for the inequality that shows us that x is in between -8 and +4. So if it's in between two numbers, I know that it can't be C. My graph is not going two different ways. It should be in between two numbers. And so I'm looking at graph D because this point right here is -8 and this point right here is 4. And the graph is showing me that all of the values in between those two numbers are parts of the solution. All right, lastly, number 72, we have that $1 is equal to 7 lorgs and $1 is also equal to 0.5 dolts. Kevin has 140 lorgs and 16 dolts. If he exchanges the lorgs and dolts for dollars, according to the rates above, how many dollars will he receive? So this is a conversion problem. And with all conversion problems, you can set up proportions. So I have my first ratio, which is that $1 is equal to 7 lorgs. That's how those two quantities are related, right? And so if I now want to know the value of 140 lorgs, when I set up a proportion, I have to make sure that the logs go in the same place as the logs in the other ratio. So I'm trying to find out 1 over 7 is equal to what over 140. So solving this proportion, to get from 7 to 140, we multiply by 20. So we're going to do the same thing in the numerator, and that is going to give me $20. So I know that Kevin has $20 as far as the logs go, but he also has 16 dolts. So now I'm going to set up a second proportion that shows me the relationship between dollars and dolts. And now I want to convert the 16 dolts into dollars. So I find out to get from 0.5 to 16, what do? I multiply by 32, right? 0.5 is the same thing as half. A half of 32 is 16. So in all proportions, you do the same thing above, times 32, and that's going to give us $32. So he has the $20 from the logs, he has the $32 from the dolts, and so that means that altogether he's got $52. All right, that is the last question. If you need anything explained a different way, please let me know. Otherwise, practice test number 4 will be coming up soon.